Hello, and this is Harder, and we are going to be talking about, hold on, CPM 1.2.1, proportional relationships with graphs and tables, part 2 on page 27, 26, and 27. This will finish up this lesson. Today we are going to be dealing with a young man named Doug. All right, so Doug mows his neighbor's lawn. Last month, Doug's neighbor paid him $55 for 6 hours. What's the first thing that we're going to need here? And this is 1-42. Yes, ma'am. You are absolutely correct. So we're going to make an X and Y table. Okay. The X and Y table, the X's is for the hours, the time, and the Y is the money. Why is this important? Because you will be using an hourly rate for forever. That's something that we all do. Yes, ma'am. Okay. You know that it's due today, yes? Okay. We can maybe get it after class. Do you need paper? You can come and get some. So hours, 0, 1, 2, 3, 4, 5, 6. I'm going to jump to 10 just because for right now. All right. Proportional relationships. What is one of the things we learned the other day about proportional relationships? What makes it proportional? Where it starts off at 0 and 0. If you show up, do you show up with added money onto your job? Usually no, not at an hourly rate. All right, so the neighbor pays this dude for 6 hours. He pays him for 6 hours. He pays this kid $55. How are we going to figure out how much it's going to cost for 1 hour? What do you think, Lawrence?
Maybe 55 divided by 6.
You are absolutely correct. 55 divided by 6 is $9.16. Good job. Good job. So, who can tell me how much it is for 2 hours? Yes, in the back. $18.32. And then it's going to be $27.48. $36.64. And then 45 for 5 hours, it's $45.80. Now, can we, out of this, make an equation? Remember, our equation is going to look like this. Y equals mx plus b. Remember, when making an equation, we need a steady rate of growth, which we have at $9.16. And if you notice, each one of these is at $9.16, right? This is our steady rate of growth, or our slope. But do we have a B? This meaning the B. No, we do not. We do not have a B because we don't have a 1 or anything right there, right? So our equation would look just like this. $9.16 times X. X being the hourly. So if you work 2 hours, you would get $18.32. If you work 3 hours, you would get $27.48, and so on and so forth. What if we worked 10 hours? How much would this dude make? How much would 10 hours be? Look at it. If we multiplied $9.16 by 10, we would get $91.16. Excuse me, $91.60, excuse me. What about 100? It would look like this. It would be 91 times 100. Well, it'd be $916. Do you see how this equation stuff is working? Now, can we do a graph with this? I guess we could. Yes, we could. Actually, do you guys mind if I turn the page? Everybody's good? I only need one quadrant because I have no negatives here. So the x's, remember, are the time, the hour, first hour, second hour, third hour, fourth hour, fifth hour, sixth hour, seventh. Okay, 13. This is our origin, our 0. And then we're going to go, I'm just going to show you 9, 16, 18 something. The next one is like 27 something, and then 32 something, and then blah, blah, blah. So if we were to do this, it would look like this. See, and we'd have a steady rate of growth. And it would have to go right through the origin. When you write your graph, make sure that you have the arrow pointing up and down, because this can continue on like forever. Watch. I will show you some cool trick. You want to see a cool trick? Yeah, I want to see a cool trick. The reason it's important to make sure that your graph is like cool is this. Let's go here. In this moment, you can see if you graphed it right, how much this guy would make at 100 hours. So all you have to do is put in the formula and look. Hold on, I went too far. See, look, here's 10 hours. Look, here's 20 hours. Or wait, excuse me, at, what did we say? This is the time. So here's, if you were at third, let's go smaller. Okay. This is the money at $400. It would be right here. For about $400, whoa, 402, 398, 43. I know, this is tricky, isn't it? We said like at 100 hours. Here's 100 hours. This is 100. He would be here at 9:16. Do you see that? Look, if you, what about 500 hours? I wish I could put a dot there, like put a pin in it. Let's see, what is this? So this is like at, if he worked for $2,000, he would have to work I mean, at 2,000 hours, he'd probably get like $19,000. Do you see how that works with the right graph? All right, let's move on. Good job, everybody. All right. Did everybody get this down? All right. Actually, I'm going to move forward this way. So on C, Johnny brags, you're not going to like Johnny. Johnny brags that he makes more money or is getting paid more than Doug. He's getting paid more than Doug right here. More than Doug to mow lawns. Johnny gets paid according to the graph to the below and the right. Who is getting paid more? How are you going to know how much this young man is getting paid? Anybody? Well, let's take a look at this. Do you see how it has 4 and then 8 down here? And do you see where it's crossing the X and the Y? That's how we're going to tell. Hold on a second. So if you look for, and this is a 50 actually, not 80, right here. For 4 hours, that young man gets paid $50. So what's the first thing I'm going to do? Yes. X and Y table. So we can show that we're dividing. So okay. So what did we say? For 4 hours, he got $50 an hour. And Mr. Lesser is right. I'm going to divide 4 into 50. How much am I going to get? I'm sorry, what? What is 4 divided into 50? $12.50. 0.08. Watch. 4, 50. 4 goes into 50 once. So it's $12.50. So the next one is going to be $25 for 2 hours. Right? How much is it going to be on the next one? Yes, sir.
37.50.
Yeah. Great. So if you take a look at this and you look at the other little guy, who is getting paid more, Doug or Johnny? Johnny. By how much more? By almost $3. Yeah. How much is it? Yeah.
$3.34.
Perfect. Good job. So first thing you should say is Johnny is getting paid more. By $3.34. I'm going to say at $12.50 an hour. Okay. All right. Did everybody get this down? Cool. Okay. Ready? Cool. Now we are going to 1-43. Feroza's pet ferret eats so much that Feroza has to buy ferret food in bulk. 5 pounds at $17.50 and 30 pounds cost $105. Make a graph for the cost of the ferret food and calculate where y is where it's 1 and y. So first off, what are we going to do? What do we always do? Yes. Love that. Yeah. So instead of me doing this for you, I'm going to make the X and Y table. £5 is $17.50. 30 pounds is 105. So you guys are going to do this for me. I want to see that you do it. It's nothing. I'm talking to myself. All right. Did you do it?
Yeah.
Okay. And you don't have the 5 written down, and why don't you have a number? What about you? Everybody should have, like, at least know what it is a pound. How much is this a pound? This is completely normal. Shoot, I buy a pound of everything. Hold on. You ready? Yeah. Good. Yes, sir. I'm coming that way. What are you going to divide by to get what you're doing. What do you mean? You just got it right.
150.
No, you did read it wrong. It's 150. You're all the way back here. It says it right here in the book. 105. And that's why you're like, yeah, now, did you do this? Yes. Now, oops. No, it's not you, it's this classroom. Okay, if you divided this by 5, you are going to get $3.50. Now, question for you. Did you divide 30 into 105 yet? Watch. I'm thinking if you guys, it's been a while since I've looked at this problem. Hold on, I think. Okay, it's still $3.50. I just wanted to check. Sometimes when you buy in bulk, especially at Costco, if you buy something small, you're going to get it at the regular price. But if you buy a lot more, they're going to reduce that price. Does that make sense? It's like, how do I say it? Oh, there used to be this dog food place I go to in Santa Barbara. If you bought the 5-pound bag, you'd pay $17.50. But if you bought the 30-pound bag, you would get it for $90 instead of the $105. Does that make sense? You get a certain amount of discount on that. But that's what it is for buying in bulk. So this is going to be $7, right? Then this is going to be $10.50. All right. So what they want us to do is, we've got this going on, right? It's a constant rate of change. So this is going to be 14. Okay, are you seeing the pattern again, right? This is very pattern-esque. So they want to know when the y is at 1, we're going to have 350. So our first question is, it's going to be $3.50 a pound. We'll just put lbs. Okay. Got that. Okay. Any questions for me before we end today? What time do we get out?
203.
2:03. Logan, you're okay. Everybody breathe deep. Now, is this proportional? Yes, because we can't buy anything for 0. So our thing is going to be, when we graph this sucker, it's going to look like this. And also we don't have negative numbers, so once again we can just have quadrant 1. Who can tell me the equation for this? Anybody? Daniel, what do you think the equation for this is going to be, sir? Go ahead.
Y equals 350 times X.
Yep, she's absolutely right. So our equation is y equals $3.50 x. Do you understand the equation? No, I don't think you guys do, because a lot of you aren't coming up with it. So the equation, hold on. I want the rest of the viewers to possibly see me. Okay, So when you're looking at this and you see the rate of growth being 350, this means that if you wrote y equals 3.50 times x, you can multiply anything, put anything in this x, and you're going to get what the y is going to be. And the y is how much it's going to cost. So watch. If I put in y equals 3.50 times 100, you're going to get y equals $350 for 100 pounds of dog ferret food. That's all it is. You can do this with anything. You can do it with money. You can do it with the price of like cereal. Whatever. You just have to have a constant rate of growth. It's got to be the same each time. Are you with me?
I am.
Thank you. I just don't feel like you are. Okay, so that's going to end this lesson for today. You don't have to cut.